So, hi sir, today's video we're going to discuss about the logic gates, truth table, and the Boolean algebra. Okay, so digital logic gates. Um, we have also seen that each gate has an opposite or complementary form of itself in the form of the NAND gate, the NOR gate, and the buffer respectively, and that any of these individual gates can be connected together to form more complex combinational logic circuits. We have also seen that in digital electronics, both that NAND gate and the NOR gate can both be classed as universal gates, as they can be used to construct any other gate type. In fact, any combinational circuit can be constructed using only 2 or 3 input NAND gate or NOR gates. We also saw that NOT gates and buffers are single input devices that can also have a tri-state high impedance output, which can be used to control the flow of data onto a common data bus wire. Digital logic gates can be made from discrete components such as resistors, transistors, and diodes to form RTL, or resistor transistors logic, or DTL, the diode transistor logic circuits. But today's modern digital 74xxx series integrated circuits are manufactured using TTLC, or the transistor logic, based on non-bipolar transistor technology, or the much fastest and low power, the CMOS based MOSFET transistor logic used in the 74xxx, 74HC XXX, the 74AC XXX, and the 4000 series logic chips. The 8 most standard individual digital logic gates are summarized below along with their corresponding truth tables. Standard logic gates. So this is the symbol and the truth table of the logic AND gate. So the symbol of the AND gate, there are 2 input and digital basic gate. So, and the truth table also is the B0011, A0101, Q0001. So the Boolean expression Q equals E plus B, or read as E and B gives Q. So for a 2 input AND gate, the output Q is true if both input A and input B are both true, giving the Boolean expression of Q equals A and B. Note that the Boolean expression for a 2 input AND gate can be written as A, B, or just simply AB without the decimal point. Okay, so the next is the logic exclusive OR gate, or XOR. So for a 2 input OR gate, the output Q is true if either input A or input B is true, giving the Boolean expression of Q equals A or B. So this is the symbol and the truth table of OR gate. So the truth table is the B0011, A0101, the Q0110. The Boolean expression Q is equal AB. Read as A or B, but not both gives Q odd. So the next is the single input logic, or the NOT gate. So there are only one input in the NOT gate. So for a single input NOT gate, the output Q is only true when the input is not true. The output is the inverse or complementary of the input, giving the Boolean expression of Q equals not it. So this is the symbol and the truth table of the NOT gate. So the truth table is A01 and the Q is 10. So expression Q equals not A read as inverse of E gives Q. The next is the NAND gate. For a 2-input NAND gate, the output Q is not true if both input A and input B are true, giving the Boolean expression of Q equals not A and B. So this is the symbol and the truth table of the logic NAND gate. So the B is 0, 0, 1, A 0, 1, 0, 1, and the Q 1, 1, 1, 0. So the Boolean expression Q equals AB, read as A and B gives not Q. So the next is the NOR gate. So NOR gate, for a 2-input NOR gate, the output Q is true if both input A and input B are not true, giving the Boolean expression of Q equals not A or B. So this is the symbol and truth table of the NOR gate. So the truth table is 0, 0, 1, 1. The B is 0, 1, 0, 1. The Q is 1, 0, 0. The Boolean expression Q is equal to A plus B, read as A or B gives not Q. The next is the logic OR gate. So for a 2-input OR gate, the output Q is true if either input A or if input B is true but not both, giving the Boolean expression of Q equal to A and not B, or not A and B. So this is the symbol and the truth table of OR gate. The Boolean expression Q is equal A plus B, read as A or B gives Q. Okay, so the next is the NOR gate. For a 2-input NOR gate, the output Q is true if both input A and input B are the same, either true or false, giving the Boolean expression of Q equal to A and B, or not A and not B. So this is the truth tables of and the symbol of the NOR gate. So the symbol Boolean expression is Q is equal to A, B, or read as A and B the same gives Q11. Boolean algebra. What is Boolean algebra? Boolean algebra expressions can be used to construct digital logic truth tables for their respective functions. As well as a standard Boolean expression, the input and output information of any logic gate or circuit can be plotted into a standard table to give a visual representation of switching function of the system. The table used to represent the Boolean expression of a logic gate function is commonly called a truth table. A logic gate truth table shows each possible input combination to the gate or circuit with the resultant output depending upon the continuation of these inputs. For example, consider a single 2-input logic circuit with input variables labeled as A and B. There are 4 possible input combinations, or 2 to the power of 2 of off and on for the 2 inputs. However, when dealing with the Boolean expressions and especially logic gate truth tables, we do not generally use on or off, but instead give them bit values with which represent a logic level 1 or a logic level 0 respectively. Then the 4 possible combinations of A and B for a 2-input logic gate is given as input combination 1 off is off or 0, 0. Input combination 2 off is on or 0, 1. So the input combination 3 is on is off or 1, 0. Input combination 4 on is on or 1, 1. Therefore, a 3-input logic circuit would have 8 possible input combinations, or 2 is to the power of 3, and a 4-input logic circuit would have 16, or 2 is to the power of 4. and 4 input logic circuit would have 16, or 2 is to the power of 4, and so on as the number of inputs increases. Then a logic circuit with a number of inputs would have 2n possible input combinations of both of off and on. So in order to keep things simple to understand, in this tutorial we will only deal with standard 2 input type logic gates, but the principles are still the same for gates with more than 2 inputs. So that's all, and thank you.